Hello friends, welcome to engineering tutorial. So here is another question on electric field. So the question is that four charges of values plus 5 microcoulomb, and 2 minus 5 microcoulomb are placed at the four corners A, B, C and D of a square of side 1 meter. Calculate the electric field at the center of the square. Okay, so we have here is the data. Let us draw the diagram. So we'll draw a square. Okay, this, okay, and this. We have the four corners. Okay, this one, this one, this one, and this one. Okay, let us name them A, B, C and D. So we have here plus 5 microcoulomb, plus 5 microcoulomb. Here we have minus 5 microcoulomb, minus 5 microcoulomb. So here let us join these diagonals through dotted lines because we'll need it. Okay, this is the center. This is the center. O, let's call it O. We have to find the electric field at this point, at the center. Okay, so let us imagine that we have a unit test charge placed here. Okay, a unit test charge means 1 coulomb, we'll consider that. That is the whole principle of calculation of electric field. We assume that there is a unit positive test charge, and then on the basis of that we calculate the electric field, which is E equals to F by Q, that unit positive test charge. Okay, well, so here AC, if we use these are all 1 meter. Okay, the side of the square is 1 meter. So here AC equals to BD, that is equal to how much? Root over of 1 square plus 1 square using Pythagoras theorem, which is equal to root 2. Okay, that is the value of AC and BD. Now AO equals to BO equals to CO equals to DO. That is equal to half of AC or half of BD. That is equal to 1 by 2 into root 2, which is equal to 1 by root 2 meter. This is root 2 meter, 1 by root 2 meter, or it is, we can write it as 0.707 meter. Okay, this is very important, these calculations. So now electric field at O due to the plus 5 microcoulomb charge at A, that will be, okay, electric field at O due to A, that is equal to 1 by 4 pi epsilon 0, the charge placed at A by how much? AO whole square. The distance is AO whole square, which is equal to 9 into 10 to the power 9 into 5 into 10 to the power minus 6 by 0.707 whole square. This is a vector. Okay, electric field, that is a vector. So it will be, it is coming around 9 into 10 to the power 4 Newton per coulomb. Okay, now let us denote it. This vector will be in this direction. Okay, it will be electric field at AO whole square. It will be in this direction, like this. Okay, that is EA vector in this direction, because it will be repelling type, the force will be repelling type, so it will be directed away. Now please pay attention. The charge at B, it is also same, plus 5 microcoulomb. The distance between B and O is also equal to AO, which is equal to 1 by root 2 meter. All the values are the same. All the values are the same. So electric field at O, due to the plus 5 microcoulomb charge at B, that will also be equal to same, because every value is equal, 1 by 4 pi epsilon 0 QB by BO whole square. It is the same as this, all the things are same, so it will be same as this. That will be equal to this, 9 into 10 to the power 4 Newton per coulomb. Only difference will be in the direction, that EB will be directed along this. Let us use color. It will be directed along this line, in this direction, This is EB vector. Magnitude is same as EA. Okay, EA vector and EB vector, they are same in magnitude, but the direction is in this. Now, here the electric field at O, due to this minus 5 microcoulomb charge placed at C, it will be EC. Here I am only concerned with the magnitude. Okay, the magnitude I am talking about, it will be 1 by 4 pi epsilon 0 QC by CO whole square. See, QC charge has the same magnitude, 5 microcoulomb, negative sign, that it is a negative charge, but the magnitude is the same as that the charges placed at A and B. It is the same magnitude. Distance, the gap, separation CO is also equal to 1 by root 2 meter. So the magnitude of EC will also be equal to EA and EB. It will be the same, 9 into 10 to the power 9 into 5 into 10 to the power minus 6. Here I am not putting the minus sign, I will specify it in the direction, don't worry about that. 0.707 whole square. It is 9 into 10 to the power 4 Newton per coulomb. Since it is a negative charge, the electric field will be directed towards it, and it will be in the same direction as EA vector. Okay, so the same vector which represents EA vector, it is the same vector that represents EC vector. EA vector and EC vector, they are equal. Okay, EA vector and EC vector, they are equal. Their magnitude is equal, their direction is also equal. Okay, they are directed in the same direction. This is a negative charge, we have assumed a unit positive test charge at 0, unit positive 1 coulomb. So there would be a force of attraction between the two, and the electric field will be directed in this direction. Similarly, minus 5 microcoulomb charge placed at D, okay, that will also be equal to same thing, magnitude is the same, 1 by 4 pi epsilon 0 QD by DO whole square. Same thing, now we'll simply put it here because it will have the same value. Okay, it will be same, but the only difference is that the direction will be in the direction of EB vector, okay. ED vector will be in the same direction as EB vector. So here if you notice, here EB vector is equal to ED vector and EA vector is equal to EC vector, because they are all are equal in magnitude, okay. Here EA vector let me use a different ink here. EA vector magnitude is equal to EB vector magnitude is equal to EC vector magnitude is equal to ED vector magnitude. All are equal in magnitude, which is equal to 9 into 10 to the power 4 Newton per Coulomb. But direction wise and magnitude wise, EB vector and ED vector, these two vectors are equal because they are equal in magnitude and equal in direction, same direction, and EA vector is equal to EC vector. So the resultant vector EBD vector is equal to 9 into 10 to the power 4 Newton per Coulomb plus 9 into 10 to the power 4 Newton per Coulomb. Why? Because EBD vector resultant is equal to EB vector plus ED vector. The same direction they are, that is 18 into 10 to the power 4 Newton per Coulomb. That is EBD vector. You please pay attention here. It is like this. EBD vector, the resultant of B vector and D vector. Similarly, EAC vector, the resultant of A vector and C vector, which are in the same direction, it is equal to EA vector plus EC vector. Same, 18 into 10 to the power 4 Newton per Coulomb. That is this direction. EAC vector. And they have an angle of 90 degree. This angle is 90 degree. Okay, this angle is 90 degree. So this angle will be 90 degree, and hence the resultant of these two vectors, which is the net electric field at O, which is the resultant, this is the resultant vector, resultant electric field at O, which is equal to ERO vector, the net resultant electric field at O, which is equal to EBD vector EAC vector magnitude whole square plus EBD vector magnitude whole square root over, that is the magnitude, which is equal to 18 into since they are all equal, see EAC and EBD, they are equal in magnitude. C vector magnitude is equal to EBD vector magnitude, let's call it E. So it will become 2E square. Okay, please pay, I'm just trying to simplify it. EAC vector and EBD vector, they are equal in magnitude, we are calling it, let's say, E. Okay, so we'll put the value here, it will be 2E square, which will be equal to root 2 E, which is equal to root 2 into 18 into 10 to the power 4 Newton per Coulomb, which is equal to 25.45 into 10 to the power 4 Newton per Coulomb. That is the net resultant electric field, the magnitude 25.45 into 10 to the power 4 Newton per Coulomb. That is the net electric field intensity. So this was the question. It was easy because all the charges there were of equal magnitude, the separation distance was same, only two were positive, two were negative, so the direction of the electric field was equal for two charges, and for the other two charges it was different. So we evaluated all of them, then we use laws of vector addition to get the resultant. Okay, this is the result which we got. If you would have directly put 18 into 10 to the power 4 whole square also, you would have got the same result. But here, just to simplify it, I just used this. Okay.